next lesson is on power and radical functions. This is section 2.1 from your book. So we're going to talk about what is a power function, what is a radical function, and then what those graphs are going to look like based on some simple rules. So a power function is any function that can be written in the form f of x equals a times x to the n. So we have some coefficient a, and then we have x raised to the power n. When graphed, you can determine the end behavior. End behavior we know is when x goes to either negative infinity, that's the left end behavior, or as x goes to positive infinity, that's the right end behavior. So we can tell what the end behavior is going to be and what the graph will look like based on a couple things about a times x to the n. So you can know when a is positive or negative, that's important, and when n is even or odd. So a positive a would be positive something, maybe 2x to the n. A negative a would maybe be just negative 1 times x to the n. So here's positive versus negative a. N being even or odd, we're just talking about x squared would be an even n versus something like x cubed, that'd be an odd n. So n we call the degree of the polynomial. So if we have 5x cubed plus 4x squared plus 2x plus 5, or something like that, then this is a third degree polynomial based on our highest n. And 5x to the third is our leading coefficient. So we have 5x cubed, that becomes our leading coefficient. So back to end behavior. When a is greater than 0, we have some things in common. When a is less than 0, we have some things in common. So let's look at a is greater than 0. As a is greater than 0, on our right end behavior, we notice we have rises on both of these. When a is less than 0, we have a fall on our right end behavior. So as x goes to infinity, our f of x is going to negative infinity. When n is even, you'll notice what happens is that our left end behavior matches our right end behavior. So for a is greater than 0, our right end behavior was a rise on our right end. And when n is even, then we're going to get a rise on our left end behavior. For a less than 0, we know we have a fall on the right end. When n is even, we're also going to have a fall on the left end. So it's going to match. When n is odd, we have the opposite situation. So for a greater than 0, we had a rise as we were going to positive infinity. For n is odd, so this is an x cubed, an x to the 5th, x to the 7th, we have a fall instead because we're doing the opposite of our right end behavior. And so for a less than 0, when n is odd, we had a rise on our left end because we had a fall on our right end. Now when we look at radical functions, a radical function is any function that can be written in the form f of x equals radical n over x to the p. So we know this in radical form where we have some radical, and it could be a cube root or a square root, and then we have some x to the p under that radical. And our p could be 0, our p could be 1. What matters in this situation is our n. So for radical functions, it's important to determine how the graph will look based on the index n, and whether this index is even or odd. So square roots versus cube roots, that's what we're talking about here. If we have a square root, for example, and this also would work if we had a 4th root or a 5th root, comparing our even and an odd, but you'll notice the difference between the graphs of even and odd indexes. For an even, we sort of just have the one side. We have the positive range of this. For an odd index, we have a reflection around the origin, and we have both sides. So we have our half of a parabola, essentially, for the even index, and then for our odd index, we have that half of a parabola, and then a half of a parabola going the other way at the connection point, at that A. Now for these two given functions, our range for this square root of x minus 5, we know that we had moved that to the right 5 based on what we know about transformations, but we do have a range that's from 0 to positive infinity. For our odd index, we have a range that goes from negative infinity to positive infinity. Now, we know that based on our rules from transformations of functions, if we add a number at the end of this radical, if we add some k or subtract some k, this is going to cause a vertical translation. So we don't always know that our range is from 0 to infinity for an even function, but we know what the graph looks like. It's that half of a parabola. All of the other rules for transformations of functions still apply. So this is all written right here, and you guys can look at that, or you can look back on that lesson as well.